What's up, friends? Murray here. We're on the next week of chemistry. Last week we were talking about the atom. This week we're going to talk about how it works. Before I get into the slideshow, I want to show you what you want to have up right now if you're following along with the video or you're trying to review. In Google Classroom, there will be this assignment that's titled Week 2, Day 1 Guided Notes. This is what we're doing for the front half of the class. For the front half of the class, we're working on this. We don't need anything else up. It's all you need up for the front half of the class. Okay, a little bit of a do now. So this do now is on that sheet that I just presented to you. I want you to try and make some answers to these questions right now. So why is this atom over here called carbon? How could you change the name of this atom? It's currently carbon. You could change it to a different name. How would you do that? Describe how. Over here, we see neutral atom. We saw that in our homework, we can change this name. What does neutral atom mean? Pause, take a couple seconds to think about that. Why is this atom named carbon? It's named carbon because of the number of protons it has. It has got all the red protons, 1, 2, 3, 4, 5, 6. 6 red protons means carbon. Because of the name is controlled by protons, how would I change this? I could add a proton, I could subtract a proton, I could add 2 protons. All of those changes to the protons would change its name. What does the phrase neutral atom mean? Neutral atom means that its charge is neutral. And we're going to talk about that today. That was in our homework. But charge depends on the number of protons. We got 6 of them. And electrons in the outside, the blue ones. 1, 2, 3, 4, 5. Ooh. Wait. Oh, sorry. My little screen is covering the last one. It's down here. 6. That's probably easier. Oops. Actually, I don't really know if my screen stays put where I put it. I've got a little like thing on Zoom. Don't worry about it. I want to take a little quick moment of appreciation. This moment of appreciation is for my brother. His name's Jamie. I love him a ton. If you're following along the worksheet, the next thing down off the do now is to take a second, write in who is your hero. I'd love to read those, find out who your hero is. I really look up to my brother. He's a great human being, and I'm glad I have him in my life. I also live with him. It's pretty dope. All right, last class. Last class, we learned about how atoms make up everything in the universe. A little caveat here. If you want to find out about that caveat, you're going to have to come to office hours. Atoms are made up of 3 different subatomic particles. We learned the names of those last class. Protons and neutrons. We knew that those are found in the center, the nucleus. Electrons are found in the outside, the orbitals. Take a second to pause, a little meme for your troubles. All right. This class, what's different is now we're going to talk about what do atoms do? And what are the roles of all the subatomic particles in what atoms do? So if atoms do things, the subatomic particles that make up the atoms are clearly going to help them do the things that they do. This GIF right here actually is from a Nobel Prize winning video done by IBM, the people that make computer parts. These are actually, each individual little dot right here is a carbon atom. So we've got a whole bunch of carbon atoms to make a little stick figure of it's called The Boy and His Atom, which is a play on an old movie film called The Boy and His Dog. It was the first time anybody had ever captured film of a singular atom, and they represented it by a boy playing with an atom. It's kind of cute, kind of cool, little piece of chemistry history right there. Nobel Prize winning too, pretty dope. Why are we learning about atoms? So atoms are the building block of everything. So of everything, let's think of a couple examples. Water. Water, pretty essential. You always drinking it. Is water wet? We're going to find out about that later. But water is made up of hydrogen atoms and oxygen atoms. If we're talking about cell phone materials, all the things that make your cell phones work nowadays, you got touch screens, all these fancy Wi-Fi capabilities, those are actually way new compared to cell phones of the early 2000s. And that's because we started using new atoms inside of cell phones. These atoms are called rare earth elements. And here's a couple of them. For example, there's gadolinium, yttrium, tantalum. There's a couple more of the rare earth elements. Those are all found in your phone. They're extremely valuable for obvious reasons. And they do really, really special things. We might get to that in the later part of the course, but they're kind of unique. Talk about nuclear fuel, uranium atoms. Like those are, if you're talking about nuclear fuel, the thing that makes nuclear power plants give you energy, that's all found in uranium. Gold chains, gold atoms, maybe. If you've ever bought like a gold chain and it's turned your neck green, or you ever bought gold earrings, quote unquote, and it turned your ears green, we're gonna find out about that later. Are those gold atoms? We'll figure it out. Got a little examples here. This water photo actually is from one of my favorite photographers, Ronnie Horn. Ronnie Horn does really cool photography and poetry. Like they overlap poetry on top of the pictures of water. It's really, really cool. You can check it out. Ronnie Horn, I'll maybe put it in the description or something. New LGs. I'm a big Android user. I think Apple stuff it's okay. But like if you're actually trying to get a phone that's worth the money that you pay for it, I would go LG, I would go Android. Some takedown, some nuclear things, nuclear reactors, and you know, our man's 2 chains. Gold chains? Maybe. All right, I'm gonna talk about 3 new big ideas today: mass, stability, and charge. Let's start with the first one, mass. Looking at these 3 subatomic particles here, we have a proton, we have a neutron, and we have an electron. Just looking at these, I tried to draw them to like how big they actually are compared to one another. I couldn't really do it because the electron would be so much smaller. If you had to guess, which subatomic particles are heavy and which are light? Pause and make a guess. So when we're actually comparing the mass of these things, you might guess like, ooh, protons, neutrons, big, probably have mass. Electrons are actually so light that they're 0. So here's that in notes form, and if you're following along on your worksheet, there's a spot to write this in. I'm gonna actually show it. So note taking, remember, is a learning goal. So you got an appreciation for your hero. You got to write in which subatomic particles are heavy, which ones are light. And right here, you see this? When I've got these blank little lines here, when I'm doing guided notes, which I'm probably gonna do a lot this year, for at least for online, you wanna erase these, you wanna highlight it by double clicking it, erase it, and then replace it with what I have. So in this first blank, it would be protons and neutrons have a mass of 1, and then electrons have a mass of 0. So there's going to be more spots along this worksheet where you have to replace the words. I'm going to let you know that. I'm not going to show you again, though. I'm going to let you know that. Take a second to pause, get these definitions down. And the reason I have M&Ms, so the reason that I have the M&Ms is if you step on a scale, you probably have before, you get your weight. The difference between the protons and neutrons and counting their mass and then saying like, oh, I've got 10 protons, 10 neutrons, my mass is 20 because I got 10 protons, 10 neutrons. If I also have 20 electrons, you might say, Murray, but what about those 20 electrons? Those have weight, don't they? They can't be 0. I saw them on the screen. Well, think about it this way. If you're like an average weight person, the difference between like protons and neutrons getting counted and protons, neutrons, and electrons getting counted is the same thing as if you step on the scale and then say you step on the scale again, but you accidentally had 10 M&Ms in your pocket. The scale's not gonna be able to tell that you had 10 M&Ms in your pocket. Those things are so small in mass that it's really hard for it to tell the difference. The same thing with like an atom. If I'm weighing an atom, I only really see the protons and neutrons because the electrons are so small by comparison. Take a second to pause, think about these questions to yourself. You're going to want to use chemistry vocabulary to explain this. So why do you have mass? You have mass because you're made of atoms, and atoms have protons and neutrons. What's a way you can increase your mass? You can eat food that has more atoms, therefore putting more atoms into your body. Easy explanation here. Okay, take a second to look at these 2 images. Sort of image on the left, image on the right. Pause. What is the same? What is different? 3 things that are the same, 2 things that are different. Pause. The 3 things that are the same: the name, helium, the number of protons, 1, 2, 1, 2, and the number of electrons, 1, 2, 1, 2. What is different? The number of neutrons, 1, 2 neutrons over here, 1, 2, 3 neutrons over here. Another thing that's different, this one is labeled as stable, this one is labeled as unstable. I want to show you, because these are, you clearly probably remember this from our assignment here. The way that you show that on the, what do you call it, simulation, is down here. It says show, element, neutral ion, stable, unstable. You click that, boom, stable shows up. Add another neutron, unstable. Take it away, stable again. That's a quick little hint. So again, here is a moment where you can pause and get down these notes, because those are going to be on your guided worksheet right here under stability. Only some combinations of protons and neutrons make stable atoms. Other combinations make unstable atoms. Just like we saw up here, 2 protons, 2 neutrons, stable. 2 protons, 3 neutrons, unstable. This is a stable combination of protons and neutrons. This is an unstable one. So I got a question for you. You're going to pause and think about. How can you make a stable atom into an unstable atom without changing its name? Pause and think about that for a second. What I would do is I can't change the number of protons and neutrons, or sorry, I can't change the number of protons, but I can change the number of neutrons. Just like in that helium atom, 2 and 2 made it stable, but 2 protons and 3 neutrons made it unstable. So I could just add a neutron. Or if an unstable combination has less neutrons, I could remove one. So here is another thing about stability. This is a process of nuclear fission. This is what makes nuclear energy happen. So I want you to make a sentence using all of the following words: fission, neutron, unstable, and nucleus. Take a pause for a second. The sentence that I might make up right now is that a neutron hits in a stable atom, combining and making it an unstable atom. The nucleus splits into 2 nucleuses. Actually, the word for that would be is nuclei. That's an example sentence. Whatever one you make, I'm probably going to like it. Okay, sorry for the rough transition. Charge now. So we have a thing called charge here. Take a second to pause, and what do you notice about this? So we got the same orange proton, gray neutron, and blue electron. But now we've got a plus, a 0, and a minus here. When we think about this, it's because protons have positive charge, electrons have negative charge, and neutrons have 0 charge. You might be asking yourself, like, Murray, what is charge? Well, charge is actually kind of a hard thing to describe. It's not like mass. It's not like something that has weight. It's this new fundamental property that comes from the atom itself. So the way that we're going to describe charge is fundamentally using the parts of the atom to describe it. So you're saying, like, Murray, what's charge? You'd be like, well, charge is what protons and electrons have. What do they have? They have opposite charges too. Protons have plus, electrons have minus. You might see this somewhat familiar to magnets. If you think about magnets at the positive end and a negative end, or it's going to be somewhat like that, but it's going to be a little bit different. The way that it's going to be different is because for each subatomic particle, you have to count +1 or -1 depending on what it is, or you count 0. So protons get a +1, neutrons get a 0, electrons get a -1. So you can just ignore the neutrons. So we think about this. I got 1 proton, my charge is +1. I got 2 protons, my charge is +2. I've got 1 electron, my charge is -1. I got 2 electrons, my charge is -2. I got 1 proton and 1 electron. I go +1, ooh, but I gotta cancel it out because I have a -1. My charge would be 0, that's my net charge. When we think about this, let's now not have it in those like little simple pictures. Let's go back to our representation of an atom. Let's think about this. Where would this fall on the number line? If this line represents charge, is it at 0 charge, 1 charge, 2 charge, or is it at negative charge? -1 charge, -1, -2 charge, or -3 charge? We'll pause and think about that. Okay, so we got 2 protons. Go up to 1, up to 2, because those both have +1 charge. Ooh, but now I got electrons, 1, 2. I got to count back. Go from 2 to 1 to 0. Ooh, this one has a charge of 0. So same thing here, folks. Let's think about this. Pause and think to yourself. Okay, so we got 2 protons. Count up 1, count up 2, electrons. Count back 1, count back 2, count back 3. So because we got 1, 2, 3 electrons. Remember, up for protons, 1, 2, back down for electrons, 1, 2, 3. We're at -1. That's what the charge of this atom is, this atom of helium. What about this final representation here? We've got 1, 2 protons and 1 electron. You can count up 1, up 2, and then count back 1, 2 electrons. So we are on the positive end here. These are positive charges. So something you might want to recognize now, and this is in your notes, follow along in your guided notes, pause and take this down. An atom's net charge, its overall charge, is its number of protons minus its electrons. That was easier than using the number line, because if we think about this, you think about this as 2 protons minus 1 electron. What is 2 minus 1? It's +1. What about this case? We got 2 protons, 3 electrons. That's 2 minus 3, which is -1. And in the last case, this was 2 protons minus 2 electrons. That's 2 minus 2, that's 0. Charge seems a little bit hard to work with at first, but I promise it'll be easy over time. We'll get some practice. I'm gonna do some practice questions right now. Pause and think about these after I ask them. I'm an atom with 5 protons, 5 neutrons, 5 electrons. What is my mass? Pause. Okay, so we got 5 protons, 5 neutrons. Each of those has 1 mass each. So we got 5 times 1 plus 5 times 1. Ooh, but electrons have no mass. These don't count towards mass. So it's 5 plus 5, it's 10. Mass is 10. So we got 5 protons, 5 neutrons, 5 electrons. What is the net charge now? What is the net charge? Pause and think. So if we think about this, it's protons minus electrons. So that's 5 minus 5. That's going to give us 0. Let's change up those numbers. We're asking about net charge again. Read this. Take a sec. So we've got 5 protons. Neutrons don't count. 3 electrons, that's 5 positive charges, 3 negative charges, that's 5 minus 3. That's going to give us a +2 charge. All right, this would be a break in class. Take a second to check out this album if you want. It's electronic, it's really cool. It's one of my favorites that's come out recently by Botany, End of Summertime Forever. Okay, so this is the first thing that's assessed today, and then we're going to get on to the second thing that's assessed today. This back half of class, there's 3 learning goals attached to this. This one is our note-taking learning goal. This one is our modeling learning goal, plus another part of modeling, where we're sort of explaining the things that happened, the changes that happened. We're gonna get into that, but here, let me show you what we're doing for the homework review. The homework review is all the way at the bottom of your guided notes today. At the top, I've put my answers, Murray's answers, to the 3 questions that I found important off of the homework. That's question number 5, question number 7, question number 9. If you're wondering, Murray, what homework are you talking about? That's this homework, the homework due Wednesday at noon. And I'm talking about question number 5, 7, 9. You are going to take your homework and compare your answer to number 5, number 7, and number 9. And in the boxes down below, you're going to tell me, what did you learn from these, from what I wrote, from my answers, compared to what you wrote initially? You have to add what you learned or what you missed. There's going to be something, probably. There's very few people that got any of these perfect. And that's totally fine, because this was just an exploration. So you need to add something that you learned or that you missed from my answers compared to your answers. So you're gonna need your answers up, and you're gonna need to compare them. That should take about 10 minutes, at least 10 minutes to do that. This is a learning goal, this is assessed. If you just say, I learned nothing, I'm not gonna pass you on the learning goal. You gotta tell me you learned something. Okay, so that's the first part. That's one learning goal. This is one learning goal. And then this is 2 learning goals. This is part of the thing that's going to be titled Week 2, Day 1 Assessment. In class, this is going to be done in pairs. You're going to have available to you the simulation. And you need to use this. You have to use a simulation for this. So you've got this simulation up here. It's going to look like this. I really recommend you need to turn on the stable, unstable button down here. If you don't do that, you're going to have a bad time, I promise. You're starting out with a list of definitions. You don't need to do anything with this, but it's there for your help. It's just like notes summarized. That way you don't need to look somewhere else for notes. This has like the summary of all the type of notes that you need. It's got the mass of the protons and neutrons. It's got the charge of the protons and electrons, and it has their definition too. Those definitions probably going to be helpful for the extension questions. You've got this representation of an atom. You can feel free to make it. You don't necessarily need to make it to answer these questions, but I recommend that you do. The next slide, slide number 4, you need to make your own nitrogen atom. It's got to be named nitrogen. If you're not making a nitrogen atom, you're not going to pass this. You need to make sure it's stable. We learned about that stable, unstable button down here. Make sure it's stable. You have to make it have a net charge of +2. How do you do that? That's up to you. And lastly, after you do all those things, you have to take a screenshot and insert it. Something that looks like this. This is a screenshot that I took of boron. It's clearly not a nitrogen atom, it's a boron atom. It's an unstable one too. This would not be good for this one. You got to make your own. To take a screenshot, I'm going to show you right now. You can, most of you all are working on Windows. So at the bottom, you're going to click the little Windows button, Shift and S, or you can open up a thing called snipping tool. You would like search in the bottom of your screen. You'd search up the word snipping tool, and you click enter, and it would pull it up. And after you pull up snipping tool, it'll look like this, where you can drag over what you need. You're going to drag over the picture of the atom. You're going to clip it. It's going to take that picture. It's going to be on your computer. You need to drag that picture wherever it's getting saved. If it's in your downloads, if it's on your desktop, it depends on your settings, where it is. You need to take that screenshot and put it in here. If you don't put that screenshot in there, that's the whole point of this. You take the screenshot of the atom that you make. You have to make sure it does these 3 things. These 3 things, and the 4th one's just an instruction. These next 2 are level 4 questions. I'm looking for a couple of sentences for this one. If you're like explaining this, you're gonna have to use a couple of sentences. I'm not even gonna read it. You can read it. For this question, you have to use this new periodic table, which is similar to the one in this element tab here, except it's a little bit different. It's got some helpful hints for you. And you got to use this question and find out which element on this periodic table you're going to use the letter symbols here. Like if you thought the atom was beryllium, you'd write in Be. Or if you thought the atom was boron, you'd write B. That's why they got the little letters right there. This is just further explaining how to take a screenshot. Here's a YouTube video if you need it. That should be it for the day. A reminder on the things that are assessed. It's this set of slides. This is worth 2 learning goals. This homework review at the bottom of today's assignment page, that is assessed worth 1 learning goal at the bottom. I think that's it. Check out that album. It's dope. That's it. See ya. Peace, folks.